All right, and the last screencast is properties of congruence. So, you may recognize some of these from algebra, right? The reflexive property, the symmetric property, and the transitive property. But we need to make sure we have a distinction between equalities and congruence. So, all of the equalities have equal signs. They're literally going to be measures. So the measure of a segment, how long it is, the measure of an angle, how big it is. So equalities are always measures. Versus congruents are actually saying the things are the same. Not the measures of how big, but the actual things. So congruence always has the congruent symbol. And it's the actual thing. So over here we have the measure of angle A versus the actual angle A themselves. We have the measure of angle B versus the actual angle B with congruence. The measure of segment CD and the actual segment itself. Okay, so reflexive property, let's go through each one. Reflexive property, you're literally looking in a mirror. The exact same thing is on both sides. It's the same number, the same measure, right? Measures are numbers. So over here we could say 4 is equal to 4. That is a reflexive property. A number is equal to itself. But we can't just replace these with numbers because these are the actual things themselves. Segment AB, angle A. So reflexive is the thing is equal to itself. The symmetric property is you are switching what is on each side. So if I have, AB, segment length AB is equal to length CD, then I can say CD is equal to AB. So you have two things, right? You have two expressions. You have an if-then statement. And then you're switching the order. So if angle A is congruent to angle B, I can say B is congruent to A. You're swapping what's on each side. It's symmetry, right? The left's equal to the right's equal to the left. And then transitive. So in algebra, you would say A equals B and B equals C. Therefore, A equals C. That's similar to how it is. If measure of angle A is equal to measure B and measure of angle B is equal to measure C, then I can say, guess what? Measure of angle A and measure of angle C are congruent. So let's name the property each statement illustrates. So first, this is symmetric, right? We see these two are just swapping which side they're on. So this is symmetric, and then this is going to be the congruence, right? It's a congruent symbol, so it's congruence. This is reflexive. It's the exact same thing on the left and right side. So it's the reflexive. The thing is equal to itself. The length is equal to itself, and it's the equality, right? You know that because the equal sign versus this one was the congruence. All right. If angle P is congruent to angle Q and Q is congruent to R, skip the middleman and say P is congruent to R. So this is the transitive property, and this is of congruence. We have a bunch of congruent symbols. That's how you know it's congruent. If A equals B, then, this is supposed to be A, B equals A. Okay, well, it seems to me like we just swapped those two. So this is the symmetric property. And so this is the symmetric of equality because there's an equal sign. Let's do this one. Okay, so angle DEF is congruent to angle DEF is congruent to itself. So whenever it is itself, we say reflexive, but this is the congruence. And lastly, we have if x equals y, and y equals z, skip the middleman and say x equals z. So this is the transitive property of equality. Because it's an equal sign. All right, properties of equality. These are all properties of equality. So notice we only have equality on the left side. So we only can do these with lengths of segments or measures of angles. The addition property, you're just adding the same thing on both sides. Subtraction property, you're subtracting the same thing on both sides. So if I have y plus 5 equals 11, and then I have something like y equals 6, well, what did we do? We subtracted 5 from both sides. That would be the subtraction property. If I would have 1/4 z equals 6, then all of a sudden I have z is equal to 24. What did I do? I multiplied by 4 on each side. I multiplied by 4, so that's a multiplication property. Similar division, and this is the big one I want to make clear. Substitution property is basically just like simplifying, right? If you would simplify, but the big thing is when you're substituting a number in for a variable, you're subbing it in for a variable, aka simplifying. You know, making combining like terms on a single side. So substitution property, you can change things on one side, you know, just simplify it out. Versus division, multiplication, subtraction, addition property, you have to do it to both sides. What you do to one side, you must do to both. Okay, that's the big part. Okay, so if measure of angle A is equal to measure angle C. Here's my A and C. Okay, so what did I do? Oh, it looks like I added the measure of angle B on both sides. So that means this is the addition property of equality. All right, let's see measure of segment AB, right? The length of CAB and CD. Looks like I'm multiplying by 3 on both sides. So this is the multiplication property of equality. Okay, so I go from x plus 5 equals 7 to x plus 2. So what I did, it looks like I subtracted 5 from both sides. So this is the subtraction property. And then, okay, so if AB equals 4 and AC equals AB plus 5, then AC equals 9. Okay, so left side did not change. I still have AC. But the difference is now my right side is 9. So what I had to do was substitute in 4 plus 5. I had to substitute in 4 for AB, and then I simplified and I get 9. So that's why this is the substitution property, because I did not change both sides. I didn't add 4 to both sides. I substituted in, right? I replaced AB with the length 4, then I simplified. This is the substitution property. All right, we have a little bit of algebra review. So 5x minus 7. Okay, so we just need to solve the equation. So I'm going to add x to both sides. That's the addition property of equality. What do I do to one side? I have to do the other. Okay, equals plus 1. I don't need the plus. Let's go ahead and let's add 7 on both sides. Since this was a minus 7, I had to do the opposite operation. I had to add 7 to both sides to get rid of it. 6x equals 8. Divide both sides by 6, and I have 8 over 6. But you have to simplify the fraction, so this is going to be 4/3. Part B, distribute this out. So I have 2x minus 3 plus 1, 4x, and then 4 times 8 is 32, so it's minus 32. Combine like terms. Negative 3 plus 1 is negative 2. Okay, so subtract 2x from both sides. I have negative 2 equals 2x minus 32. Add 32 on both sides. Running out of room, so I'm going to come up here. So I have 30 is equal to 2x. We divide by 2 on both sides. You get x is equal to 15. All right, number 3. I need to distribute this negative out. So negative times a negative is a positive. A negative times positive 5 is negative 5. Distribute this out. So I have 2x minus 4. Can combine like terms here. And I just rewrite whatever I had before. Let's go and let's add x on both sides. So that way I can get rid of it. I'm going to add 4 on both sides. So I have negative 1 is equal to 3x. So to get x by itself, I divide by 3. So x is negative 1/3. And then this is the answer I'd prefer, is this fraction. Okay. And lastly, we have 1/2 x. So I'm going to subtract 5 on both sides, get rid of that. 1/2 x is equal to negative x plus 3. If I add x on both sides, I have 1.5 x. So I have a half x plus 1x equals 3x. I'm sorry, equals 3. So I want to do the fraction over on the side. So if I have like x over 2 plus x over 1, because that's just 1x and a half x, I can make a common denominator by multiplying by 2 over 2. So I have x over 2 plus 2x over 2. So that's going to give me 3x over 2. Which is the same thing as 1 and 1/2 x. All right, equals 3. So I could do this in two ways, right? I'm going to show you two ways. So if 3x over 2 equals 3, you could multiply by 2 on both sides. Goes away. I have 3x equals 6. Divide by 3. I get x equals 2. Or I could go through and multiply by the reciprocal. Instead of saying 3 over 2, right? I multiply by 3 over 2, so I can multiply by 2/3. Because the 2 and the 3 cancels out, and I'll be left with x is equal to 3 times 2/3. The 3 goes away, and I'm left with an answer of 2, which is the same thing. I did two things in one time. And we're skipping this last question. Not needed. It's just, we're good. And then that's it for this lesson. Let me know if you have questions.